Hi there, this is just a quick video of the solar hot water heater I designed a couple of days ago. Well, that's pretty much it right there. I went to Home Depot and bought two 50-foot rolls of black plastic tubing, 1/2 inch, coiled it up carefully on a piece of plywood and propped it up in the sun. I ran a couple of lines to the house off a splitter here, so I've got one line running to the collector, the other just to the garden hose. But quickly again, out about 20 feet to the yard, 100 feet of coiled black tubing. Just a couple of things. I can get 130-degree water pretty much from 8:39 in the morning till about 4 in the afternoon. If you take the water out specifically between like 11 to 1 or 12 to 1:30, I've seen it as high as 150-degree water. So really hot water, and all I had to do was curl up some piping and put it in the sun. The only other thing I wanted to show you here was you do buy the type of valve you want to hook the hoses together at the inlet and right there. So since it is 1/2 inch tubing, every 50 feet is almost exactly 1 gallon, so 100 feet there, that's two solid gallons right there, heated up in 30 to 45 minutes. Again, to get to the highest temperatures, maybe 45 minutes to an hour. So any questions, let me know. Hey there, just a quick video of another little solar water heater I set up the other day. Similar to the other one I posted a while back, but this one I made out of the 1/4 inch black poly instead of the 1/2 inch. I wanted to see if I could get higher temperature water, and if I could get that higher temperature a lot faster. So it seems like that is the case. Right there, that's just 50 feet coiled up. There's another second coil I'm going to chain to it. But I'm getting temperatures as high as 158 degrees Fahrenheit, and that's on a day where it's only about 90 degrees out and the water sits in there for say 30 minutes. So not too bad. I can actually get around 120 degree water coming out of that at a steady state if you run the water through constantly without stopping it. So I figure if I chain a couple of them together, I'll be able to get, I'm actually thinking about putting, maybe doing a 200-foot roll. I bet I could get like 130, 135. That's pretty freaking hot water. So that's cool. If you do let the water sit in there for a little while, you can get, well above 150. Interesting thing about that is if you live in an area where, you say you got the bacteria, the parasites, disease causing stuff in the water, you can just let it sit in there. You can pasteurize water at about 150 degrees Fahrenheit. That'll kill just about any living thing in the water. So making it a lot safer to drink. So this might be an option to help, pasteurize water in areas where, it's just not that clean. Of course, it's not going to take the sediment or trace chemicals out, but anyway, hey, for $6, what can you do? That whole thing costs $6, just $3 for the tubing, 50 cents for the dowels, 50 cents for the plywood, and I think it was like $1 something for the staples. But if you have those, some of this stuff you probably just have laying around the house. So anywhere from $3 to $6, most people could make something like this, and just chain a couple of them together or coil up some more, and you've got fast, free, hot water from the sun. Any questions? Let me know.
Hi, this is Nick the Cat, and I want to show you how to build a water heating solar panel. This was one of my many projects since I returned to the US. First, I built a jig to draw a straight line down a 52-inch long, 1-inch diameter copper tube. This tube will be a header for a solar panel. Next, mark that line every 2 inches down the pipe for a total of 21 locations, centered around the center of the pipe. Line up all of your headers and mark all the other pipes identically. Once all the locations have been marked, it's time to drill a pilot hole. I use a 1/8 inch drill bit for the pilot hole. Another jig holds the pipe in place during drilling. Drill the pilot hole as close to the X as possible in the 21 locations. Then follow up the pilot hole with a larger bit. My small copper tube has a 3/8 inch outside diameter. The smaller copper tube is 1/4 inch inside diameter. It is carefully unrolled on the floor to prevent kinks. I use 60-foot rolls because it divides perfectly by 90 inches. The larger diameter tool allows the smaller copper tube to be marked and cut at exactly 90-inch pieces. The copper pieces still have bows in them. Carefully bend the copper tube as straight as possible. I have found that smacking against a flat surface does a nice job. Sand the ends of the tubes. Then cover with solder flux. The fun part is trying to shove each of the small copper tubes into the header pipe. The prior tubes often want to fall back out. Take a look down the copper pipe and verify all the tubes go in far enough, but not too far. If they go in too far, they won't reach the other header. Solder the copper tubes into the header. Be sure the header is hot enough or you won't get a good solder joint. For the second header, begin by soldering the two outside tubes to the header first. After they've cooled, then shove the rest of the pipes in place. And then, of course, solder them. Soldering headers indoors is okay, but the next step, soldering 5/1000 inch thick copper sheet to the copper tube, is best done outside due to the amount of smoke you will create. Press the copper sheet securely against the copper pipe. I found 3/4 inch black iron pipe did a reasonable job. Have lots of solder available. I use 50/50 lead-based solder for this part of the project. I also use a water-based flux for this part of the project. This jug was good for about 3 solar panels. At this point, you can straighten the copper tubes that are wedged between the black iron pipes. You will spend about an hour soldering the copper sheet to the pipes. The soldering process causes the copper to ripple. This is fine. The other side of the sheet is the face of the panel. I sandblasted the face of the panel to roughen up the surface for painting. I used Rust-Oleum high temperature paint without a primer and sprayed the face of these panels. I let the panels hang in the basement for about a month to let them off-gas before putting them into the boxes. For building the boxes, I cut a rabbet in the back of each pressure-treated 2x4, then drilled holes where the headers will exit the sides of the panels. I assembled the boxes with screws, including the plywood back, which fits into a rabbet in the back of the 2x4s. What is missing from this video is that each box has 3 2x2s running across the back of the panel. This supports the copper core solar panel and strengthens the plywood back. After I verified that no screws go through the header holes, I took one of the side 2x4s off, placed a layer of fiberglass insulation in the box, and place the solar panel on top of the fiberglass. The 2x4 side was then replaced. To pull the solar panel down, I put several screws with washers through the copper sheeting and into the 2x2s that were used to strengthen the back of the panel. To complete the project, the panels were mounted on a rack, tempered glass was added, and flashing used to cover the edges of the glass. Silicon radiator hose was used to connect the panels. This allows for disassembly later if necessary. PVC pipe was cut lengthwise and used to cover the radiator hoses. How hot can these panels make water? We pump 60-degree water from a garden hose into the set of panels, and steam came out the other end, after the panels have been sitting in the sun for a while. Collecting heat is one thing, but storage and delivery is another. I used a drain-back system for my solar heating system. In this system, there is no water in the solar panels unless the pumps are running. Once the pumps come on, the panels fill with water, and when the water reaches the top, it runs back downhill to the tank. When the pumps shut off, the water drains out of the piping and back into the tank, so there's no water left in the panels at night. For the water storage tank, I began by digging a large hole, building a box in the hole, and after giving the insulation a good check, I insulate the box with 4 to 6 inches of foam. The box is lined with a felt liner before installing an EPDM pond liner to hold the water. A 30-foot square pond liner weighs over 400 pounds, so get some humans to help you out with it. I also lined the top of the box with a pond liner, and after it was carefully heaved in place, I insulated the lid with both foam and fiberglass insulation. Inside the box, you can see how I used large stainless washers and a lot of screws to hold the pond liner to the lid. You will also see the suction port for the pump, the heat exchanger for the radiant floor heating system, and various tubes for placing temperature probes into the tank. Once the access port is sealed up, the only opening is just large enough to put a garden hose into the tank. Because the water in the storage tank can hit 160 degrees, a mixing valve is used to lower the water temperature entering the radiant floor system down to 120 degrees. Water leaving the storage tank passes through PEX tubing, insulated with foam, and covered with PVC pipe to keep the groundwater from contacting the PEX. This trench also carries a power cable to operate the pumps. The radiant floor system is composed of a pump and 1,000 feet of PEX tubing stapled up using aluminum heat distribution panels. There are better distribution panels on the market, but you can make these yourself using aluminum flashing. Finish this by placing a layer of insulation a couple inches below the PEX tubing so you drive the heat up through the floor. And there you have it, a heat storage tank and distribution system. I chose a 4,000 gallon water tank so I could store enough heat to span 4 or 5 cloudy days. I hope someday to add enough solar panels to collect double my daily heat requirements. The first 12 panels provided 50% of our heat for the first 2 winters. We are now up to 20 panels and anticipate approximately 80% of our winter heat will come from the sun.